Good evening, everyone. Myself Ravin. Today I'm going to talk about arithmetic logic unit, that is ALU, expansion of ALU. So this is a table of contents, assumptions, bus concept, and CPU building block. And the simplest computer building blocks is and what's ALU and say typical semantic symbol of ALU. Semantic means data of symbol of ALU. So let's see what is assumptions, bus concept, and CPU building blocks, and what is ALU and the symbol of ALU. This is assumptions of ALU. Number representations, ones complement, twos complement. Ones complement changing into zeros in ones and ones in zeros. And arithmetic operands add subtraction as usual. Floating point numbers as 0 0.1, 1.2. This is floating point concept. And register in CPU accumulator, program counter, and instruction register. Accumulator it is used to store the information in the memory. Program as usual set of instructions and instruction registers. So let's see what is bus concept. This is the review of bus concept. So CPU, ALU registers and control and memory and input and output operations. So you had seen the bus concept, that is in the way in the symbolic of a bus. So this is the data bus, address bus, and control bus. Data bus is a unidirectional, and address bus is a bidirectional, and a control bus. It controls overall flow of data. So this is the CPU building blocks, registers, PC, ACC, and control unit, arithmetic registers. Um, you can visible that there is the multiplexer and program counter and decoder, arithmetic logic unit. So this is it will store the data in the RAM, that is temporary memory. So let's see what is building blocks works. So building blocks works in the way of register pair, program counter, and accumulator, and it is transferred into arithmetic logic unit operations. So this is the simplest computer building blocks. So this is ALU. So it will store the data and sends to the RAM, which is stored to the CPU for the further process. So what is ALU? ALU stands for Arithmetic Logic Unit, and ALU is a digital circuit that performs arithmetic addition, subtraction, logical operations, and or not. And operation has uh, when one and operation has zeros and ones, and or contains addition operations, and not it has only one input and one output operations. And he is the person John von Neumann proposed at the ALU in the 1945 when he was working as EDVSA. So he is introduced the ALU in 1945. So this is the typical semantic symbol of an ALU, and A and B the inputs of the ALU, and AK operands, and R represents output or result, and F represents code or instruction from the control unit, and output D represents output status. It indicates cases such as carry in, carry out, overflow when data is high, and division by zero. So let's build an 1-bit ALU. This is 1-bit ALU. Can do logical and or operations. Result A and B when operation is 0. So this is according to the AND operation truth table, and OR operation truth table according to the A and B operations. The operation line is input of mux. This is my multiplexer. So this is built by in the use of multiplexers to get the result. So this is an 32-bit ALU. By paralleling the 1 bit, we have seen 16-bit, 8-bit ALU. This is 32-bit ALU. To as for modification and the logical circuit, we can create bigger ALUs. So I think it's understandable and clear. So thank you.